Hello, my name is Lyndon and I live in the Herefordshire village of Moccas. Living in Moccas has given me a wonderful opportunity to learn all about this magnificent 1871 organ built by Walkers and Sons of London. During the recent restoration, which took around 6 months, this organ was completely dismantled and Nicholson's of Malvern took it to their workshops to do a complete restoration of all the components of this instrument. When it came back from their workshops, I was very fortunate to be able to follow all the reconstruction of the instrument, and through doing that I learned a lot about how the instrument works. The restoration was a hugely complex and expensive project and was supported by a range of donors, including the National Lottery Heritage Fund and local donors too. Well, here I am sitting at the console of this instrument, and with the covers removed we can see some of the incredibly complex action of the organ. This is called a tracker action organ, and what that means is it's completely mechanical and there is a direct connection between the manuals and the pipes. That connection involves tracker rods, levers and other moving parts. So this is a wonderful opportunity to see inside some of the workings of the organ. We have the part you normally see, which is the 2 manuals and the ends of the draw stops. This is the great organ on this side, that's the swell organ and the coupler drawers. But inside we have a whole lot of other things that we can see, and it's lovely. For example, the swell keyboard. Well, the swell keyboard goes all the way back to here, and then we have various parts of the action. That's the swell action there, which I'll show you in a moment. We have the coupling machine, which couples the grate to the swell, and then we have part of the grate action above. And we'll be able to see while I'm playing that works beautifully. I mean, it's a beautifully engineered piece of equipment. It's wonderful. And just in there alone there are thousands of components. All these little felt pads, there are threads on all of those. These are all adjustable. All this is, just in there alone there are hundreds of actual components in the organ. You'll also see the action moving inside, and what actually happens in the organ is that eventually the action goes up the wall and over the top to the swell box above. So it goes quite a long way and it's quite complicated, but it's beautifully made. Well, now we're looking at part of the action for the great organ. This is the manual of the great organ here, and inside the organ we can see part of the action for the grate, which is at the top here. And the first thing to say about this part of the action is that it is the same width. All that along there is the same width as the manuals. But then when we look above here we can see this part moving. This is called a splay beam. We can see the action moving at this point. And what's interesting about the splay beam is that it spreads out the action from the width of the manuals to the width of the soundboard, which is above my head. That's important because in this organ it happens on the swell as well. We have parts of the organ which are the width of the manuals and parts of the organ which are the width of the soundboards, and in order to get that change of width, in the case of the great organ we use this thing called a splay beam. In a tracker action organ we have parts of the action which pull, which are called tracker rods, and we have parts of the action which push, and they are called stickers. In this particular view we can see this piece of wood here moving up and down, and that's a sticker. That is actually pushing the back of the manual, the keyboard, that's pushing that up. And then if we come out to the front and we come to this point here, you can actually see the part of the splay beam which is connected to that sticker. So the sticker is pushing the back of the splay beam, and that makes the front of it move down. And then just above here we can see a tracker rod which is pulling to open a valve in the soundboard to allow air into that note on the soundboard. Right, now I will demonstrate the grate action, which you will see the keys obviously here. You will see the grate action inside and also the splay beam showing how it spreads out the action to the width of the soundboard above. To the left hand side, when now the organ is open, we can actually see that the draw stops for the swell organ go all the way back. They go all the way back and then round a corner, up the side of the chamber and connect with the swell box, which is several feet up in the air. So it's amazing that this fully mechanical instrument has so much more going on inside than I think most people realise. On this side we have the great organ draw stops, and this really is interesting because the draw stop goes to about there, and then it goes off onto this black metal, on these black metal rods here. So what we can see here is it's the 15th stop on the great organ, and there is a pivot point here. It then joins onto a black rod that rotates, and it is going up out of sight. That then operates a very complicated wooden mechanism which eventually moves the sliders on the great organ soundboard, and that allows the air to flow into the pipe. So when it's drawn, that stop is drawn, that has moved a slider in the soundboard which is enabling the air to flow into the pipes. And it's beautiful engineering at its best, you know, this is wonderful. This is the swell to grate coupler. Inside the organ we have the coupling machine. This couples the grate to the swell, and we draw it like that. So this part of the organ is called the coupling machine, and this couples the grate to the swell, and it's a brilliantly engineered piece of equipment. It clamps the two actions together, so you can actually see that's with it off. Both manuals will work separately. The coupler comes on, and now the grate and the swell organ are joined together. So I'm now going to play using the swell to grate coupler, and this means that when I'm playing on the grate manual, the swell manual will operate as well, and you will see the keyboard up here working while these keys are being played, and you'll see everything going on inside as well, which is quite exciting really. Now we're going to look at the pedals on the organ, and the way the instrument is set up at the moment is using the grate to pedals coupler and the swell to grate coupler. So the pedals are connected to the grate, and then the grate manual is connected to the swell. So while I'm playing with the pedals, all the other parts of the organ will be working as well. was lovely. I actually, that worked in one go. Now we're going to look at the pedal board in more detail, and we can see first of all that it's a straight pedal board, and it's laid out exactly like a keyboard. So you've got the white notes here, and the dark brown pedals are the black notes of the keyboard effectively. And of course, if you press these, you get the notes from the board-on bass pipes. So with the cover removed here, we can see part of the mechanical aspect of the pedals. And the first thing to notice at the top here, these are the top of tracker rods. These connect to the pedals, and then at this point they connect to a roller board which goes right the way to the back of the church, and then they attach to trackers that go all the way along the wall to the pipes themselves. Now in front of this we have this beautiful looking piece of equipment. This is called a roller board, and this is all connected to the fact that the pedals are much wider than the manuals. Because obviously when you use the coupling device, when you want to couple the pedals to the manuals, you have to get from the width of the pedal board to the width of the manuals, and to do this we use a roller board system. And with this note here, for example, you can see that the pedal is pulling down on this tracker rod here, and then the movement goes across to this point and then goes up another tracker rod there, and that's then connecting directly to the manual, the great manual. So this is how the notes get from the width of the pedals to the width of the manuals. And let's play a few notes so you can see it working. While the cover's off again, we can see two more foot controls. These two here are called combination pedals, and they enable the organist to change stops without having to draw them individually by hand. So you've got two combinations of stops with those pedals there. Okay, on the right hand side of the pedal area we have this lever. This lever controls the shutters on the front of the swell organ, and when the panel's in place there's a locking slot so that it goes across like that. Okay, and what I'm going to show you now is the difference in the sound on the swell organ between when the doors are open and when the doors are closed. So at the moment the doors are closed. I'm just going to play a chord on the manuals here. When you press the pedal down, the doors open and the organ becomes louder. And then exactly the opposite happens when you close the doors by raising the pedal. And what you'll notice now is I'm going to play some notes high up on the keys here, and while I'm using my feet, the pedals, the keys will actually be working down at the bottom of the organ because the pedals are connected to the lower keys of the manuals. So let's see what happens here. Okay, so let's have a look at the stops on the left-hand side of the manuals. The horn diapason on the swell organ is a new stop. It was made by Nicholson's for this restoration, and I went to the workshop and saw the metal components when they'd been freshly cut. This stop was installed at this stage to replace a stop that was put in the 1970s, and the purpose of the horn diapason was to return the organ to a sound that was more akin to an instrument of the 19th century. And this is a demonstration of what the horn diapason sounds like. Now we're going to look at the oboe stop, which is also in the swell organ, and the oboe is different from all the other stops on the instrument because the pipes on the oboe rank are what are called reed pipes. Reed pipes contain a reed which vibrates, and that creates the sound in those pipes. It also gives it a very distinctive sound, which I will demonstrate now. Now we're going to look at the stops of the great organ, which are situated here on the right hand side of the manuals. And the great organ creates sounds which you would define as a typical organ sound. And in order to explain this, we're going to start off by looking at the open diapason. The open diapason is called an 8-foot stop, and it just so happens that bottom C on the organ is an 8-foot open pipe. And I can play that now. And that's the lowest pitched pipe on the great organ, and it's an 8-foot pipe, as I say. So we'll just have a listen to the open diapason on its own. You can already tell that it sounds very much like an organ sounds when it's accompanying hymns. But then we can build this up, and the next stop to add to the mixture is called the principal. The principal is a 4-foot stop, and what that means is that all the notes on the principal are 1 octave higher than the open diapason. If you halve the length of the pipe, you get an octave higher. So the principal and the open diapason together are sounding an octave apart. Now, as I say, the open diapason and the principal are an octave apart. Now, an organ is using what are called harmonics to, harmonics are part of sound, and the organ is picking out these harmonics, and we have the 8-foot open diapason, we have the principal, they are an octave apart. We then have the 12th, which is, as its name suggests, a 12th, an interval of a 12th above the pitch of the open diapason. When we add the 12th, the sound becomes quite a bit brighter. And continuing with these harmonics, we have the open diapason, the principal is an octave above that, the 12th is a 12th above the pitch of the open diapason, and finally we have the 15th, which is 2 octaves above the open diapason. So when all four are working together, we get an even brighter sound. Another thing that you have in an organ is stops which replicate other instruments, and on the great organ we have a flute and a clarabelle flute. The clarabelle flute is an 8-foot stop, so it's pitched the same as the open diapason, and the flute is a 4-foot stop, so it's an octave higher. So we can hear a little bit of the clarabelle flute on its own. We then add the flute, which is an octave higher, we have a much brighter sound. The final stop that I want to show on here is called the dulciana. The dulciana is a very quiet 8-foot stop. So it's pitched the same as the open diapason. It might even be the quietest stop on the organ, and it sounds like this. Starting with the dulciana, we will build up a chord and show how the instrument builds up. On either side of the central section of the organ we have these wonderful cabinets that contain the bourdon bass pipes, and this is a very unusual feature of this organ to display them in this way. But in order to see the pipes themselves we need to open the door. Now these are the bourdon pipes. They are constructed from wood, and here we have bottom C. Now this is an 8-foot wooden pipe, but because these are stopped, it creates the effect of a 16-foot tone, so it's an octave lower than an 8-foot pipe would be. And this is bottom C, and then because of the way the pipes are laid out, we have D, we have E, and we have F sharp that we can actually see in this view here. Before I actually play the notes, you will notice that we have the mouth of the pipe visible here, and also the air flows up through these feet here from the wind trunk, which runs along here. So this is bottom C, which is this pipe here. We have D, we have E, and the final pipe that is visible here is F sharp. In addition to these 4 board-on bass pipes, we can see some of one of the pipes from the great organ. The reason it's here is because literally there wasn't room to fit it into the main organ itself. So it's a very large pipe, and it is sitting over here. What makes this particularly interesting is that the conveyancing pipe, as it's called, which is this red pipe along here, is used to send air from the soundboard of the great organ, which is way over above the manuals. It sends the air from there along here and into the pipe, which runs all the way up almost to the top there, so it sort of disappears. But it is a good opportunity to see some of the metal conveyancing pipe, of which there is a lot more, up in the organ chamber above the manuals. When asked what I love about this particular organ, I often mention its size and complexity when compared to the proportions of the church itself. I think of the difficulties the designers would have faced fitting 574 pipes into a relatively small space. And of course it took 7 years for the organ to be finished. This is such a fine example of Victorian engineering, and with all the stops pulled out, the organ really is very loud. The magnificent sound seems to match so well the ravishing case designed by George Gilbert Scott Jr. and Charles Zema Kemp's wonderful paintwork. That said, the organ also has some lovely gentle tones provided by stops such as the horn diapason, the dulciana and the flutes. It really is a fine instrument.